Hello and welcome back to our programming series for chemistry students. I'm glad you're here. Introducing user inputs for interactive scripts. In our last video, we learned about defining and calling Python functions, and we used our molecular mass function to calculate the mass of compounds. You might recall we called it like this: molecular mass 1, 4, molecular mass 2, 6, etc., and then printed the results. This way of working, where the arguments are fixed in the code, is known as hard coding. While it works, it's not very flexible. What if we want to calculate the mass for any combination of carbon and hydrogen atoms during the execution of the code, not just the ones we wrote down initially? The key to this flexibility is accepting user inputs during runtime. The input function. Python makes this super easy with the built-in input function. Let's see how it works. X equals input, print you entered plus X. When Python hits the input line, the program pauses and waits for you to enter a value and hit the enter or return key. That entered value is then assigned to the variable X. The print X line then displays the value on the console. If you run this and enter, say, minus 0.123 and hit enter, the console will show minus 0.123, you entered minus 0.123. A quick note, the top line, minus 0.123, is what you type and is updated dynamically as you type. The second line, you entered minus 0.123, only appears after you press enter or return, causing the print command to execute. Prompting the user. The previous example was a bit bare. It didn't tell the user what to enter. We can fix this by adding a prompt message directly inside the input function. X equals input, enter something, print you entered plus X. Now when you run this, the console immediately displays the helpful prompt, enter something. If you then type 3.45 into the console and press enter, the output will look like this. Enter something, 3.45. You entered 3.45. Dealing with string input, typecasting. Here's a crucial point. Is the value 3.45 that you entered and stored in X a number? Surprisingly, no. Let's see what happens if we try to treat it as a number. X equals input, enter something, Y equals 1.0, Z equals X plus Y, print sum of X and Y plus Z. If you run this and enter a number for X, Python will throw a type error. Can only concatenate string, not float, to string. The reason is that the input function stores all input as a string by default. Trying to add a floating point number, y, to a string, x, causes this error. You can verify the type of the input using the type function. X equals input, enter something, print, type x. Even if you enter a number, the output will be class string, meaning it belongs to the string class. Typecasting to the rescue. To use the input as a number, we must manually convert it using a process called typecasting. Since our molecular masses are often floats, let's typecast to a float. X equals float, input, enter something. Now, if you check the type with print type of X, it will correctly show class float, meaning it belongs to the float class. You can also do the typecasting in 2 steps if that's clearer. X equals input, enter something, X equals float X. Updating our mass computation script. Now let's apply this to our molecular mass script. First, in the main body of the script, we need to delete or comment out the old hard-coded calls. Print molecular masses, print molecular mass 1, 4, print molecular mass 2, 6, etc. And end with printing the results. Next, we'll replace them with interactive input. NC equals input, enter number of carbons, NC equals int NC. We typecast to int since atom counts are integers. NH equals input, enter number of hydrogens. NH equals int NH. Typecast the second input to int. Print molecular masses, print molecular mass NC NH. Notice we are typecasting to int because the number of atoms must be an integer. Run this script. For methane, you'll enter 1 for carbons and then 4 for hydrogens, hitting enter after each one. You'll get the molecular weight. The great thing is that you now have the freedom to enter any values for carbon and hydrogen, making the program interactive. Taking multiple inputs at once. What if you want to enter both numbers on a single line? Python can do this by entering values separated by spaces and then using the split function to assign them to separate variables. We can modify our script to look like this. NC NH equals input, enter number of carbons and hydrogens, dot split. NC equals int NC, NH equals int NH. Print molecular masses, print molecular mass NC NH. Run the script, enter 1 and 4 for CH4 separated by a space and hit enter. You'll get an output similar to this. Enter number of carbons and hydrogens 1 and 4, molecular masses C1H4 equals 16.043. Custom separators. You don't have to use a space. You can specify another separator, like a comma, by passing it into the split function. NC and NH equals input, enter number of carbons and hydrogens, comma separated, dot split. NC equals int NC, NH equals int NH. Print molecular masses, print molecular mass NC NH. Now, if you run this and enter 2 and 6 for C2H6 separated by a comma, the console will display enter number of carbons and hydrogens, comma, separated, 2 and 6, molecular masses, C2H6 equals 30.07. So there you have it. You've learned how to take single and multiple user inputs and, most importantly, how to use typecasting to ensure your data is in the correct format for calculations. We've made our molecular mass calculator interactive by using the input function and a little typecasting magic. In our next video, we're going to cover loops. This is a powerful concept that lets you repeat code many times, which is essential for automating tasks in chemistry. Thanks for watching. See you in the next one.